In this problem, we need to divide two complex numbers and write the answer in standard form, a plus bi. So there is one standard trick that we always use to solve problems of this type. And that trick involves multiplying the fraction by 1. This does not change the value of the fraction, but what we're going to do is we're going to represent that 1 in a way which allows us to simplify the expression. So, what we're trying to achieve in this problem is to make the denominator into a real number. We would like to get rid of the imaginary part at the bottom. And the way to do this is to multiply the complex number in the denominator by its so-called conjugate. And the conjugate of a complex number is the same number but with the sign of the imaginary part changed. So if the number is 5 plus 3i, then its conjugate is 5 minus 3i. So we do not change the sign of the entire number, we simply change the sign of the imaginary part. If that was a plus, it becomes a minus. If it was a minus, it becomes a plus. But now, we would like to keep the value of the original fraction intact, so we also multiply the top by the same number. So effectively what we've done is we represented 1 as a fraction 5 minus 3i over 5 minus 3i. And the presence of that 5 minus 3i, as I said, is not an accident. It has this specific purpose of simplifying the denominator. So let's multiply the fractions. So we multiply the numerators. And we multiply the denominators. So at the top, we need to multiply two complex numbers, so let's just distribute carefully all the terms. So we have 6 times 5, then 6 times negative 3i, so minus 6 times 3i, then minus 4i times 5, and then plus negative 4i times negative 3i. At the bottom, we have something which looks like a plus bi times a minus bi. So we can use the difference of squares formula, and we know that this is going to be the difference of these squares. Let's simplify this further. At the top, we have 30 minus 18i minus 20i, and then plus 12i squared. What we have at the bottom is 25 minus 9i squared. And now, whenever you work with complex numbers, you always need to remember that the square of I is negative 1. This is what allows you to simplify these expressions further. So we have 30 minus 18i minus 20i becomes minus 38i, and then the square of I is negative 1, so plus 12 times negative 1 becomes minus 12. At the bottom we have 29 minus 9 multiplied by negative 1 becomes plus 9. See what happened? We no longer have I in the denominator. The denominator is a real number. That was the whole idea why we multiplied the fraction by 5 minus 3i over 5 minus 3i. We got rid of the imaginary part at the bottom. Let's simplify further. At the top we have 30 minus 12, this is 18 minus 38i, and this is divided by 34. Now, we're not done yet because this is still a fraction, but we need to reduce this expression to the standard form of a complex number, which looks like a plus bi. A is a real number plus another real number multiplied by I. We're not allowed a fraction in the whole expression. But because we have now a real number at the bottom, we can split this fraction into two parts. And now see what happens. We do have that standard form. This is your number A, and this is your real number B. The last step is to reduce the fractions to lowest terms. Notice that both numerator and denominator have a common factor of 2 in both cases, so if you factor out 2, what's left is 9 over 7 minus 19 over 17i. And so this is the result of the division of two complex numbers, now written in the standard form, and that's our answer.